Recording in progress.
So onto the support, we have in advance glued the self-adhesive stickers and platforms, self-adhesive platforms on which we installed the ties, onto which we are mounting and installing the wires and the conductors, which will connect the photovoltaic modules between one another. Now the competitor ties up the conductors. So this moment, the participant cut the parts of the ties that we do not need. All the cables that are used to connect the photovoltaic modules are now connected. And the cable that should go from the photovoltaic modules and the pillars to the switchboard to the booth, we actually have connected beforehand.
Смотрите, господа, на данном...
So now, in this booth, we have installed the equipment for accumulating and storing electric energy, for its distribution, and for converting the direct current to alternating current, DC to AC and back, and vice versa. Which means that from the photovoltaic modules that we had connected before, we receive the voltage that would be the direct current, and our users, the households, they're using the AC, the alternating current. That's why here in our booth we have the switchboard, the power supply 220 volt from the outer circuit, a switchboard for direct current with circuit breakers, an inverter, an info panel, and the charge controller. We need the charge controller to monitor our batteries, inverter to convert electric current from DC to AC. So, the power supply from the photovoltaic modules comes through the cable that is within the perforated cable duct, and it comes through here. And this is the direct current, the DC that's coming here. And then the cables are going from the charge controller to the inverter. This is still the direct current. Let us turn it on, let us switch it on.
Так, в щите постоянно...
In our direct current switchboard that has 24 volt, we have the current goes through the inverter to the load. And right now, the system is working for the output, for giving out the electric energy. because at this moment there is no power coming to our system from the photovoltaic modules, because our photovoltaic modules are right now indoors, and the light is not the sunlight, so they are not able to generate real power. But since we actually laid the cable and we have charged our system from a usual power supply, we can show you the mode of giving out of the electric energy output. So we turn on the load, which would be the LED lamp.
Сейчас мы вам продемонстрируем, что показывает информационный.
Now we'll be showing you what we can see on the info panel.
Соответственно, здесь у нас
So what we've got here, the red, is the power supply that comes from the outer circuit, which is the 230 volts of AC. We have not turned it on. We work standalone, autonomously. The blue in the middle, this is the status of the inverter. This is the inversion, the charge, or off. There are three modes: inversion mode, charging mode, off mode. The green panel, the green one, is the output from the inverter. Right now, we have 11 watt. This is the power that is consumed by our LED lamp that we turned on before using our booth. In the lower part here below, the yellow panel, the yellow part is the power coming from the the photovoltaic modules. It is 0 because at this moment the photovoltaic modules are indoors. The green panel are the electric storage batteries. Their capacity at this moment, we have here the 23 watt that is used that we use from the batteries. Why is it more than 11 watt that we use? Because we have some conversion. We're converting the electric energy from direct to alternating, and we lose about 10 watt there. So now let us try and show you the mode of charging from the photovoltaic modules. We will connect it with the permanent power supply, with a direct current power supply. For that, we will turn off all the circuit breakers and all the voltage.
Отключаем щиток постоянного тока.
So turning off the switchboard for the direct current. And for the alternating current as well. DC and AC both.
Теперь отключаем.
Now we disconnect the cable that came from the photovoltaic modules to the charge control were disconnected. And connect the power supply that gives us direct current. In this case, that would be the 50 volt. That would simulate the photovoltaic modules. We connected instead of the wires that were coming from the photovoltaic modules.
Подключаем в сеть источник постоянного тока.
So we plug in the 50 volt power supply, the direct current power supply.
Наш источник постоянного тока в данный момент выдает.
Our direct voltage, direct current power supply is giving right now 53.6 volt, and there is no consumption because our device, our electric equipment is turned off, and the electric current is not coming to the charge controller. So right now we turn on all the equipment.
У нас загорается и прогружается информационная панель.
So we see the info panel is turned on. Now we turn on the switchboard for direct current.
Ждем загрузки информационной.
Wait while the info panel is loading.
Я думаю, на этом этапе можно выключить.
I believe at this moment we can turn off the lamp, unplug the lamp, so that we will be able to see the info panel better.
Так. На данный момент у нас
At this moment,
движение
the voltage here that's coming from the DC power supply is 53.7 volt, and the consumption of our electrical system is 2.55 ampere.
Сейчас я продемонстрирую.
Right now, I'll be showing you what we have displayed on our info panel.
Наша информационная панель.
Our info panel shows us now that the yellow part, that's the power supply coming from the photovoltaic modules. It shows 110 watts of the energy that's coming into the system from our direct current power supply. So if our solar power plant was outdoors in a real life energy, in real life situation, in real life environment, that would be the output of the power plant. Right now we have the charge mode, the battery charge mode, and 100 about, well, it's not permanent. There is about 100. We have some sort of margin for the direct current power supply, but about 95 watt of electric energy is coming to our batteries. Now we'll plug in the LED lamp again. We see now that we have about 100 watt that's coming from the direct current power supply. The consumption now is 11 watt, the LED lamp, and 75 watt is coming to the battery, which is the difference between the charge mode and the charge and consumption at the same time. So a part of the energy that comes from the power supply, part of it goes to be consumed by the LED lamp, and the major part, in this case it's 72 watt, going to charge the battery. So basically that's it. Thank you, everybody. If you have any kind of question, please do not hesitate to ask.
Коллеги, добрый день. Еще раз вопросы есть или нет? Есть вопрос, подсоединены ли батареи последовательно? Михаил, можете ответить, подсоединены ли батареи последовательно? Да.
The answer to the question about the batteries connected in series is yes. They are connected in series. Now, the voltage of each battery is 12 volt. They are connected in series. And in the end, the charge controller has the voltage of 24 volts.
Так. Может быть, еще вопросы?
Are there any other questions?
Коллеги, ну, давайте, если у кого-то еще вопросы.
If you have any other questions, please do not hesitate to ask. And meanwhile, I'd like to sum up what we have discussed in these 3 days. We have demonstrated you the full cycle of mounting the pillars, photovoltaic modules, installing the electric switchboard, the connecting of the switchboard, and putting it into operation. And it is very important for us to sum up the skills that we are able to develop during this kind of training. Right now you have a slide here where we have the cross-cutting skills as well as unique skills. One of the principles of training our competitors and the future specialists that we are going to bring up is actually that separating cross-cutting skills that can be trained and not only within installing the photovoltaic modules. And these are some skills in which we already have significant experience. The electrical installation skills, the electrical tool usage skills, the mounting skills, and at the same time, there are unique skills that are actually about working with specific mounting tools, installation tools, working with specific equipment like photovoltaic modules. So we believe that these are the skills that can be trained on the premises of different education facilities. And we have several education facilities that specialize in preparing and to bring up the specialists of electrical installation. And that's where we will be working. We will be training the competitors on the electrical installation skills, and where we need to train the skills for mounting metal constructions, we will be training on the premises of the facilities where the Russian team uses it. So what I mean to say is that we are going to use different facilities that already have experience, that already have the experience in bringing up the specialists with the skills that we need, and we can use that to combine a very effective training program using the experience that we have already gathered while working on other skills. Now, to the question of about what software do you use for designing, that we're going to use to design, we were using the Beam, the Revit for the design, as well as Rhino. And we'll be trying to use any software that we will be able to. Right now, we're in the process of choosing the optimal software. But then again, I'm ready to discuss the software that you believe would be optimal for these purposes. Are there any other questions? At this moment, it is Beam, Rhino, and Revit, the software that we use now for design.
Can you please repeat the name?
Sorry? I don't hear you. Can you reply, please? Repeat, please.
What is the name of the software for the designing of solar power plants?
What is the name for the... Maybe you can type your question because I can hear only the parts of it.
Name of the software.
No, name of the software or name of the software.
Like we have PV-Syst, Homer, PV-Sol, Helioscope, like that.
Oh, in Russia we use, I can type it just now, SCADA. It is usually using on solar stations and wind stations. Программное обеспечение SCADA.
The SCADA is the software that is usually used on the solar stations and wind power stations. But if we take a look at the WorldSkills International Infrastructure List, there will be different software, and we are not using it at the moment yet. The one that is in the infrastructure list in the WorldSkills International Competition, that is mentioned there. The one that's mentioned there, we don't use it yet. In Russia, we use the SCADA software.
And what about UAV programming? UAV programming.
UAV programming.
UAV programming using software to conduct UAV flights.
Я хочу попросить помощь переводчиков. Я не очень понимаю этот вопрос. Да, я переключилась. Да, сейчас я вас слышу. Да, повторите, пожалуйста, вопрос, я последний не поняла. Дронами. Я, к сожалению, не могу прокомментировать, какое программное обеспечение мы будем использовать при работе с дронами.
About the UAV flights, we have not really started the training, so I am not able to give you any comment at this moment, unfortunately. I believe I will be able to reply you by the end of next month. I believe that we will choose the software by the end of January.
Переведите мне, пожалуйста, вопрос на испанском. Я его не понимаю. Да, я вас слышу.
So, as you have mentioned that the unique point is in your training program, carry out the commissioning work.
Please wait for a second. Please wait for a second while we're translating the question from Spanish into Russian. Please wait for a bit. First, we'll reply the question in Spanish that was asked in the chat, and then thank you.
Я не поняла смысл этого. Каким образом мы генерируем? Если честно, данный вопрос немножечко странный. Вот. Давайте так, я подумаю над ответом, Феликс Матер, и, возможно, вам лично отвечу, потому что сейчас я не очень поняла ваш вопрос. Давайте мы с вами, может быть, в личке спишемся. Я не могу ответить на этот вопрос сейчас. Бессмысленно. Коллеги, есть еще вопросы? Я Феликс Матер отвечу чуть позже личным сообщением, потому что мне надо проконсультироваться. Я не очень поняла смысл, я проконсультируюсь с коллегами и отвечу. Можно попросить переводчика испанского написать мне по-русски вопрос, раз я передала коллегам его. Да, спасибо большое. Текст просто я не поняла. Если есть еще вопросы, то мы, во-первых, можно их писать, и мы ответим на них еще завтра. Я хочу напомнить, что завтра у нас завершающая сессия по нашему мастер-классу, по нашему скилл-кэмпу, где мы подведем итог и как бы обменяемся мнениями. Я с удовольствием послушаю ваше мнение. Если есть опыт в использовании различного программного обеспечения.
If you have any experience, so I'd like to sum up that if you have any questions, you can ask them tomorrow. You can ask them right now. You can ask them tomorrow on our discussion in our closing event tomorrow. I'd like to listen what kind of software you are using, and I'd like for us to exchange some experience. And I will be also replying to the question that Felix Matthias asked me that I was not able to reply today. So the last check if there are any questions for the moment, and if there are none for now, that would be it for today. And we are waiting for you tomorrow online for the closing event, for the closing session and discussion.